Hello and welcome to the part 2 of exploring AVRs. So in this series, I try to dive deeper into microcontroller world, embedded systems world, and see what we can do with microcontrollers without using any helpful external libraries, except for very useful ones. And I try to, in this particular series, go from Arduino to like actual raw microcontroller without any help from Arduino. In part 1, I've already discussed how to write raw C code in the Arduino IDE, and we uploaded this code to Arduino itself so that the microcontroller on that Arduino board, which is 80MEGA 328P, will blink LED that is again on Arduino microcontroller, and it worked. But today I wanted to talk about this a little more in details, and also what I want to do is to dive into inputs, digital inputs. They are a little bit different and require some different things, but what we will do today is use external button that I will hook up to Arduino, and when we press this button, LED will turn on, then when I release this button, LED will turn off. So, in previous video, I used this code that you can see on my screen, and actually this code without any additional strings that you will see here, for example, like these ones. And I've changed something else, for example, this one, and we'll go through this. So, what I did here is I removed this library that we included, and this library helps us to use microcontroller ports or registers, and these registers are just a block of memory. This block of memory is 8 bits in size, so essentially it just allows us to use this DDR-B, port B, and again, all of this I've discussed in my previous video, except these things. So if we remove this library, which I did, so I just commented it out, you can essentially remove it. And what we can do, what we can see here is we will still be able to use this code to blink an LED. And again, we use 162 bytes. It didn't do anything to the program memory. It didn't shrinkify this even more. And I'm not sure if it did something to the speed of this program execution. But what it did is it allows us to look into these registers. What do they look like inside? And essentially, we can create our own references to these registers. So first thing, what I did here is I, first of all, removed PB5, I think I called it in my previous video. So I just left it as 5. And what this means is our LED pin will be connected to the 5th bit of whatever register we will use. In my case, we use port B5 because this LED already connected to pin, which is called port B, and it turned out to be 5th bit inside that port. And again, what this define thing does for us is it just tells our compiler to take wherever we have this LED pin thing written, for example, here or here, and replace it with this number 5. We could remove this line and use here, instead of LED pin, just number 5, just like that. But we try to make our code more readable so that we can troubleshoot it better. And let's say we removed LED from 5th bit, and let's say we used 6th bit now. So we can do it just in one line. Instead of going here, then here, changing it from 5 to 6 here, we can just do it in one place. Just like that. And again, these things are called macros. It's just synonym. So instead of 5, replace this value with LED pin. So LED pin is synonym to 5. Then next two lines, we have again macros. So what I have here is DDRB and port B, the things that we already used in my previous video. And these things were defined in the AVR library, which is avr/io.h. What we tell our compiler is to, instead of this whole thing in parentheses, which we will discuss in a bit, replace it with this something called pointer something. Sorry, I forgot what it's called. Pointer dereferencer, if I'm not mistaken. So essentially, first thing, volatile. This keyword in the AVR world, I think AVR world, maybe in other microcontrollers, it just tells our compiler to not ignore this line here, because our compiler will ignore this line in the optimization process, and our compiler is very smart, so it can optimize even more our program and remove things that we never used in code. So it's very smart. Instead of doing this, we have to tell it, don't ignore this line and don't remove it, because we will use it. So essentially that's what volatile does here. We have this thing, uint8 underscore t. This is just tells what type, data type, our pointer will be. Our pointer is unsigned u, int, integer, which is just whole numbers, 1, 0, 1, 2, 3, 4, 5, and so on. Unsigned means without sign, so only positive numbers, no negative numbers. And 8 means it will be 8 bits. And if we, for example, had microcontroller with 16-bit architecture, we would write 16 or 32 and so on. And then this whole thing is a pointer. It will point to the memory address. So it just tells us, go to memory block that lives at address 0x24. And it's essentially like a real life address of your home, of your work, school, and so on. Then this thing tells us to open this block and see or read what's inside, or we can write to this block of memory. So for example, we want to put inside there 0 or 1. And this address is address of DDRB, of Data Direction Register B. Address of port B is 0x25. And again, this is in hexadecimal, so it's not 25, it's 25, but it's not important right now. So just remember that this is in hexadecimal. And where did I find these values? I will tell you in a minute. But first, I wanted to give you maybe a good analogy to whatever this thing is, whatever it means, because for me, it was a good analogy. I understood it like that. So imagine a street of 8 houses in a row. Each house has a number, as all houses do. These houses, these numbers, they are 0, 1, 2, 3, 4, 5, 6, and 7, so 8 bits. And in one house can live only one person. So let's say Mr. or Mrs. 0 or Mr. or Mrs. 1, 0 or 1. The street on which they live, we ourselves called port B, or essentially port D, port C, DDRB, DDRC. We will call it whatever we want. But the address, actual address of this street is 0x24 for data direction register or 0x25. And there are many other addresses, but for now we will only use 0x24 and 0x25. So let's say we want to move Mrs. 0 or Mrs. 1 into house, one of these houses. And in this case, it will be house number 5. So what we do is we tell them the address where these houses are located and to which unit they are going. So essentially what we do is we give them a map, and on this map we have everything labeled, and we draw an arrow how to go there. So we essentially point to that address. This address again in memory inside the microcontroller, and that's essentially what this thing does. This is a pointer, and we allow them with this star to go there. We open them, I don't know, gates or whatever. But again, it's very hard for them to maybe remember this thing, so that's why we call it port B. So it's that beautiful name of the street that's called port B or DDRB instead of this ugly thing. Then we also have a guide man that will guide them to their houses, and we tell that guide man to escort Mrs. 1 to whatever unit we chose inside port B. And this operation is actually this one. So DDRB or equals 1 LED pin, something like this, or shift 1 5 places to the left. But this whole thing you can interpret as telling guideman to escort Mr. or Mrs. 0 or 1 to house number 5 or LED pin as we called it. Then we do same thing with port B, and that's how we do this thing. But if you don't want to write this whole thing, you can just remove it and use avr/io.h library. And now where did I find these addresses 0x24 and 25? I found in the datasheet for 80MB 328p microcontroller. So you just Google 80MB 328p or whatever microcontroller you use datasheet and go into this chapter, I think, which is called register description. Inside here we have port B and DDRB, and underneath here you can find the address, which is in parentheses. I'm not sure which one. I'm not sure what is this thing, but we'll use 0x25 for port B, and for DDRB it will be 0x24. And you can see here other registers. So this one, MCU control register. I'm not sure yet what is this. Pin B, and this register we will use to read values. Actually, we'll use it in this video. And if we upload this code, it will again blink an LED every 0.5 seconds, every half a second. Right. So now what we want to do is to use digital input. So effectively just put 0 into DDRB and whatever pin we choose. So goal is to light up an LED when we press and hold button. And what we will do, first set LED pin as output. And again, LED pin is 5th bit inside port B. Then second, set button pin as input. And for button pin, I chose 4th bit inside same port B. So we'll just use port B, and inside port B, bit 5 and 4. For button, we could choose anything. I just decided to choose 4. And then we need to read button pin, and if it's high, so for example, if it's outputting either 5 volts or 3.3 volts high, we set LED pin as high also. So what we did in previous code, else it will be low. So as you can see here, I've included AVR io.h because I just don't want to write these registers and pointers. I don't even remember them by heart, so that's why we will use io.h library from AVR themselves. Next we have macros. So LED pin will be 5th bit as before, because I don't want to use any external LED. Then we need to use external resistor. So let's just use whatever we have already. Pin 5, same built-in LED on Arduino. But button, we can't use button on the Arduino because this button will reset Arduino. So we of course don't want this to Arduino be resetted. That's why we need external button. We will use capacitor. This capacitor will debounce button. And unfortunately in this video I won't talk about the hardware part of it, like how to wire it, what capacitor to use, what is debouncing. We'll use bit number 4. Then we will create something called function prototype. What essentially this does, first of all, this function here, pin setup, is just function that will set our DDR-Bs, port Bs to DDR-Bs to either input or output. I just don't want to write everything here. It'll be a little bit messy. So instead of writing all of this here in the int main function, we will separate it into a different function that I called pin setup. You can call it whatever you want. And again, this function void, it returns nothing, whereas int main returns integer, so either 0 or 1. If we have error, I think, if I'm not mistaken, it will return 0 and 1 if no errors. Name, pin setup, and void, again, inside. It just means we don't use any arguments, but we don't care about it for now. And inside DDR-B, we set it to output, so PB5, LED pin, and bit number 4 inside port B, PB4, button pin as input. To set input, we use this thing. And this is essentially kind of, not exactly, but kind of inverse of this thing. We don't do 0, something like that, because it will not work. And what we do is AND equals, we AND DDR-B with this thing. And what this thing is, it's negation not 1 into button pin. And essentially we say put not 1. And what is not 1? Not 1 is 0. Put 0 into button pin. Oh, and this one also important because we need to enable internal pull-up resistor on our button. So what is this thing? Internal pull-up resistor. Pull-up resistor is a resistor, like actual physical resistor, that will pull up. That means it will connect our pin to 5 volts whenever we don't push on the button. And again, this is one of the concepts of using push buttons, so debouncing and pull up. And if you want to know details about this, you can just Google it or watch it on YouTube, or actually ask ChatGPT. We need to enable pull up on pin of button pin, because microcontroller will read, because this is input, of course, microcontroller will read this input, and this pin that we connect button to can pick up some very low or very high frequencies. And these frequencies are considered noise. They are not what we want. This noise essentially will make our pin be either 0 or 1. It will oscillate between these values. 0, after 1 second it will be again 0, after 1 second it will be 1, for example. We don't know that. This is purely random thing that we don't know, and we don't need that. So instead of being unpredictable, we can make this pin be predictable using 5 volts and resistor. This resistor is very high value so that we don't drive a lot of current inside this pin. And again, and these are all details. Unfortunately, I will not discuss them here. Just consider that we have to use pull-up resistor on port B4. And this is essentially what this function do. Now, going back to prototype function, because our code C compiler usually always reads code from top to bottom like this, row by row, column by column. It will read something like this. And without this function prototype, let's say, it will read after this macro int main. We then go inside int main and we see pin setup. Then compiler will scream at us that what the hell is this? I don't know what this thing is. You didn't define it everywhere. But yeah, we did define it here. But compiler doesn't know this because it's not here yet. You haven't read the code. That's essentially just how C code works. Python, if I'm not mistaken, can read the functions that are after kind of like main in quotes function. So it's totally different thing. That's why we need a function prototype. And with this thing, we tell compiler that there will be a function called pin setup that has this architecture, void pin setup void. It's not defined yet, so when it goes here, it sees it, but we told compiler that expect this function, but it will be later. So just remember that we will have it later. So when it goes here, it remembers that this function will be defined after, and it just goes like that and reaches this function, reads it, and remembers that we need to take all of this and input it here. That's another thing, that int main have to be always on top of the code. It's not like something, it's not something that we have to do in C. Like compiler doesn't care if we did it like that, or if int main is the last function, but pin setup is very first function. But we, as programmers, should care, and this is kind of like a rule for programmers, not for compiler, how to write the code, how to write C code. And then inside main function, what we have is, again, while loop, that will loop forever. And now I think you need to remember this syntax, because you will be using it always when using buttons. This is just checking if button was pressed. So here what we have is pin B, which is another register similar to port B and DDR-B. Pin B just reads whatever value is inside register B. And if this condition is 0, that means button was pressed. And if our button was pressed, we need to turn LED on. So this thing. Before that, in my previous code, we toggled LED. So we just changed whatever value it was. If it was 0, we change it to 1. If it was 1 on the second loop, it will be 0, and so on. But here we just set it to permanent value. So 1, turn LED on. Else, this condition is 1. Here, instead of 0, it will be equal to 1. We turn LED off. Or if we don't do anything with button, we turn LED off. And so essentially that's all to this program. And I think the only new thing here is pin B, this syntax, if pin B and this thing, blah, 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 is just checking if button was pressed. And what else? Port B, how to turn LED on permanently and how to turn LED off. So now you know how to turn pin on, off, and how to toggle it, which means just switching from 0 to 1, from 1 to 0, and so on. Maybe function prototypes, but it's C thing, so it's not actually AVR, and enable pull-up on PB4. This thing also new. So let's just try this thing, and we'll see what we will have. Okay, so as you can see here, I have my last code uploaded, which is LED blinking. And this is the LED that we blink in my first video and that we will toggle right now. Here I have button, and this button is connected to, first of all, ground, one part of it. So my button is connected like this. these two pins are next to each other, and other two pins, they are kind of like apart from each other. So we connect this button like this and not like this. And I also have one capacitor that is 0.22 microfarads or 220 nanofarads, if I'm not mistaken. I think, yeah. Okay. So this capacitor I just chose because I read somewhere, or I think ChatGPT told me to use this capacitor, but it's okay to use this one. And I connected it in parallel with these pins. So essentially similar pins on the other side, one and second, and capacitor goes, one leg of it goes here, the other leg goes here, and the minus leg goes to the ground of our Arduino. And again, negative pin is connected here, ground, this one connected to again this pin, and the other pin, which is this one, connected to D12 on Arduino. D12 on Arduino, if we take a look at the Arduino datasheet, will be named as PB4 on Arduino datasheet or Arduino pinout. So I could choose any other pin. I just decided to choose this one. So of course, if we try to press this button, nothing happens. And now let's upload the code and see what will happen. So I've uploaded code, and actually very funny thing is that this sketch, it seems like a lot, but it uses 150 bytes, whereas the previous sketch, previous code, where we just blink an LED off and on, used 162 bytes. So we are 12 bytes lower on this program. And I think this is probably because of the delay function that we used from util delay, util something library. So yeah, now let's try to, first of all, our LED is not blinking, and now let's try to press the button and see what will happen. It lights up. If we release the button, LED goes off. Now press, release. Okay, so I think that will be it for today. In today's video, again to recap, we used digital input, then we used pin B, and we also discussed how to essentially create our own macros for registers. So yeah, that will be it for today. Thank you for watching.